little bit relaxed. Okay, I want to introduce you guys to something new that you can do in your calculator. Before we do, though, I'm going to give you a little riddle, and if you have already heard this and know the answer to it, please just give everybody else a chance to think through it and be surprised by it. So, are you guys ready? And feel free to sketch this out if you'd like. So, a bear leaves its home. Who's heard this one? A bear leaves its home and it walks due south for 5 miles, straight south for 5 miles. And then it turns and it walks due east for 5 miles. And then it turns and it walks due north for 5 miles. And it arrives back at its home. What color is the bear? Don't say an answer yet. I want everybody to get a chance to think about it. Who has heard this one before? Anybody heard this already? All right, let me repeat it. So, and again, sketch it out if you need to. The bear starts out at its home. It walks 5 miles due south, 5 miles due east, and then 5 miles due north, and arrives back at its home where it started. What color is the bear? I didn't think about that solution. It's got an enormous house. Oh, all right. Who knows the answer? What color is the bear? Nope. What is it? It is a white bear, yes. Because there's only one place on the earth where that scenario would be possible, right? Where can you walk from and go the same distance south, east, and north and end up where you started from? The North Pole, right? Because any place you go from the North Pole, any direction you go from the North Pole, you're going south, right? So if you're standing at the North Pole here, remember the Earth is a sphere, and you walk south and then east and then north again, you'll end up back where it started. So the bear must be white, the polar bear. And we're going to do polar equations. So get your calculators out. Isn't that a great segue? Get your calculators out, go into your mode button, and we've played around now with function mode. We've played around with parametric mode. We're going to try our hand at polar mode today. Let's see here. Let's go ahead and put our graphs in radian mode also, because we will be doing some stuff with angles here. And then go ahead and hit your y equals button. Be prepared to be amazed. It's not y equals anymore, is it? All right. Has anybody done polar equations before? All right, give me something I can type in here. Let's explore this a little bit. What do you want to put in? Let's put something in for one of the equations. 42x. Hey, really that big a number? Okay. 42x. Oh, it's not x though, it's theta. Huh. 42 theta. Okay, and then I'm going to do zoom. Is there a zoom polar? I can't remember. No, so I'll just do zoom 6, standard zoom. There's my graph, 42x. Okay, what else could we try? 42 theta. Say again. Let's try sine theta. That's interesting. Sine theta. Ooh, that's kind of tiny. How do you suppose we could make it bigger? 42 sine theta, that would make it much bigger. How do you suppose we could make it reasonably bigger so we might be able to see it on our screen? 5 sine theta, let's try 5 sine theta. Huh. Interesting. You want to try zoom square? Zoom square might be a better idea. Go ahead and try zoom square. Ah, that's a familiar shape. Almost looks circular, doesn't it? Give me something else to try. I liked your idea of 42 42x. Maybe let's bump it down a little bit. Let's chill that equation out a little bit. 42x is pretty extreme. What would be a similar equation? 13 is still a pretty large number. 4 is, yeah, let's try 4x. Let's try 4x. 4x. This is, I'd still say that's, when I think of like a slope, when I think of like 4x, I think of a slope of 4. That's still pretty steep, but we'll give that a shot, see what happens there. Ooh, that's interesting. I wonder what it would be if it's just 1x. Try that. Well, it's not x, it's theta. Oh, yeah. I wonder why it's stopping. Why do you suppose it starts and just stops there? Because it must be graphing an angle. Well, theta would make me think angle, so I think that's probably a safe bet. Hit your window button. I'm curious. Yeah, look at this. They've got theta min and theta max. What do you notice about theta max? It's 2 pi. Do you think we could bump that up and make it continue kind of going around? Why don't we try that? Bump theta max up to, I don't know, let's try 10. And graph it again. Now it goes further. Oh, that's, I could make it even keep going. Maybe we should make it higher than 10. Should we make it 50? Look at that. Oh yeah, that's very spirally. All right. There's some pretty interesting graphs that you can make out of this. So let me give you an example. Let's see if I can remember how this goes. I'm going to go 4 minus 3 cosine theta. 4 minus 2 cosine theta. Yeah, that's not that interesting. Let's do 2 minus 4 cosine theta. Ooh, that one's fun. It's kind of like a heart with a little loop-de-loop in the middle of it. All right, so we're not going to get too heavy into this. The goal here is not for you to know how to construct these graphs. I just want you to play around with them a bit today. So I'm going to give you handouts, and this is going to be our work for today. And what do I do with it? Oh man, it was right here. And I'm going to have you guys just kind of play around. Oh, come on now. Oh, there it is. So I'm going to have you look, this is the first page of it here. I'm going to have you look this over. There are some different types of polar graphs. You don't need notes for this. For the rest of the day, all you need is your calculator and your imagination. So I'm going to give you a bunch of graphs, and I'm going to ask you to try and match the graphs by playing around with the equations. So I'll kind of lead you through a little bit of the process here in just a second. Let me get these passed out. There we go. So if you look inside of there, you're going to see a bunch of graphs, and your goal is to come up with equations that match those graphs. You can do this on Desmos. Some of you might prefer to do it on Desmos because the graphs look a little bit nicer. If you do decide to use Desmos, let me know, and I'll show you how to get the same kind of graphs that they're showing here. But if you're doing it on yours, you just need to note a couple things, such as like this is a circle and it goes through the origin and it goes through a y coordinate of 1, 2, 3, 4, 5, 6, 7, 8. So you would want to try and make yourself a circle that went through the origin and a y coordinate of 8. That's kind of the important information there. If I were doing this assignment, I would do it backwards. I would actually start with this sheet and I would try graphing some of these things. Now, in these equations, r and theta are like your x and your y, okay? And anything else like A's, B's, C's, N's, those are constants. Those are just numbers that you're going to insert. Okay, so, and this, there should be an A out in front here on both of those. So let's do a circle. Let's start with R equals C. So R equals C. So go into your calculator and just pick me a number. C is a number. You're going to try and pick a number. Someone pick a number for me. 8. And graph it. You know what? This will go a little bit quicker if you do zoom standard and then zoom box, or not zoom square. Zoom 6 and then zoom 5. That looks kind of like a circle. Man, something's funky is going on. Are those of you with the newer calculators, you could kind of getting that blocky look to your circles also? It's more smooth. I'm gonna, yeah, it does kind of, doesn't it? Like a low resolution, like 90s style 3D video game. I'll tell you how we can fix that. If you go into your window where it says theta step, make that a smaller number. Let's try 0.05. I think that'll smooth it out. Oh yeah, look at that, like butter. All right, so there we go. That's a circle, and it's centered. Notice that circle is centered at the origin. Ah, interesting. How far out does it go from the origin? 8, which is the number we put in. Now look through your packet and see if you can find me a graph that shows a circle centered at the origin. Oh my gosh, it's like the first one, isn't it? Yeah, totally. So this is a circle, and I bet that I could figure out what its equation would be. It's going to be R equals, now we did R equals 8. What do you think this one's going to be? R equals 2, because it's going 2 out. So R equals 2. Cool. Okay. Then I might go back and I might try the other flavor of circles. So let's see here. So it says plus or minus sine theta. Let's try it with the sine. Do you guys want to do positive or negative? Positive. Okay, positive it is. Do you want to put a number in front of that sine theta? I would recommend it. Give me a number to put in front of there. 20 sine theta. I have a feeling that's going to be way too big, but we'll see. Yeah, it's going to go off our screen. We used 4 last time. You want to use 4 again? 4 sine theta? Huh. Interesting. Now it's a circle, but it's not centered at the origin. It touches the origin. And instead of the radius being 4, now the diameter is 4. That's interesting, isn't it? I wonder what would happen if we put a negative in front of that 4. What do you think? Interesting. I wonder what would happen if we change the sign to a cosine. What do you think? Yeah. All right, so let's find one that looks like this. I think number 2 looks kind of like this, doesn't it? It's a circle. The circle is kind of symmetrical about the y-axis. Do you think this is going to be a sine equation or a cosine equation? Sine. So R equals, and it's going to be something sine theta. You think it's 8? 1, 2, 3, 4, 5, 6, 7, 8. I agree. I think it's going to be 8 sine theta. I'm actually going to try it on my calculator though. So positive 8 sine theta. Oh, we said sine, not cosine. Bless you. Yeah, it's looking pretty good. This was also a circle. You guys get the idea? So this kind of goes along with these. You're going to get down to lines, play around with some lemniscates. When you do lemniscates, you actually have to graph these ones, not these. And then limosons. There's 4 flavors of limosons: inner loop, cardioid, dimpled, and convex. And it all depends on A and B. So this one you'll have to play around. Try changing the plus to a minus. Try picking A and B values that are the same, like maybe do a 3 and a 3. Try doing some where A is bigger than B. Try doing some where B is bigger than A. Try changing from sine to cosine and see what that does. And as you're doing that, you'll see some of the patterns in these graphs. and see if you can figure out how to make these graphs. And that's it. That's your work for today. I'd love for you guys to come in here on Monday and have a pretty decent idea for most of these graphs what the equation is going to be. All right, sound good? Can we do it? Awesome. All right, well, that's it. Get after it. Let me know if you have questions. If you do have questions about the projectile motion problem that you did for your homework, let me know. I'd be happy to support you with that.